For our next speaker, we have Stephan Sahm. He's an entrepreneur, data scientist, engineer, and data architect. So the floor is yours, Stephan.
Thank you very much. And thank you for being here. 10 minutes is not much, so I want to rush through a couple of things. We already heard a little bit about Pluto hooks. If you don't know about them, I think that's quite reasonable. They're a little hidden, and I want to give you some insights kind of how they work. And yeah, and first let's kind of take a look at, okay, this is typical. Okay, now we are scaled to the system. So I have two notebooks kind of just running here, and the one which I put into the description of this talk is kind of running on financial data. So this is scanning Bitcoin data from Binance and running an RxInfer model on top of it. We just heard an awesome keynote talk for RxInfer, so it's really awesome for real-time stuff. And so this is really real-time Bitcoin data, yeah. And yeah, the analysis still takes some time, but some steps. But kind of key things to understand is that we can kind of build stuff similar to this. We can build kind of channels which really kind of grab data from Binance, and we can write a line like this. So let's see when it's going to update next. Yeah, no, it's probably. No, not yet. And it's grabbing kind of data from Binance channel. And then we can aggregate this. So the key thing is really that we can build stuff like this, which is repeatedly updating itself. And we can also kind of do similar stuff, which is on a time basis. So I built kind of another macro, which is called repeat at. And these are kind of the two steps which I put together here to kind of build an RxInfer model. So we get these times from Binance, from the Bitcoin data, which is of course a bit infrequent when the changes come, and we sample them again. And we do all these sampling by using Pluto reactivity. And yeah, because time is rushing, I want to kind of give you a little insight on how this is implemented, because it's not using Pluto hooks, but the underlying Pluto features. And I think it's really awesome to just have seen this once. So this is kind of the underlying key macro. It's called repeat run. And this is then kind of built on top of this. And in Pluto, kind of, if we build a macro, the first thing is that we have kind of two different runtimes, which is really cool to know if you want to do more advanced stuff with Pluto. If the macro is run, this is kind of when the cell is initialized the first time. And when the cell is repeatedly run, then this first part of the macro expansion, is never run again. Yeah, but only the expanded stuff from the macro is run. And this way we can kind of put some state into the macro, and this is how the Pluto style works. And we have usually also some fallback. If it's not running in a Pluto process, we do something which also works without a running Pluto, so that you can include it into a file. And then we can kind of have some state on the macro level. For example, yeah, let's kind of take a look, but this is really just to track us. And then we have kind of the final expression. We track whether it's the first time when we run, and then we get some special functions from Pluto. And this is kind of also in Pluto hooks. I also put it into Joel and Pluto, my little package here. But it's the very same name. Give me rerun cell function. And with this, you kind of inject something into this code, which the Pluto runtime will replace. So the macro expansion won't kind of give you this special key, but it really replaces this key, what is here, give me rerun cell function, with the actual function. And we have another cleanup function registering. And with these two functions, the rerun function and the cleanup function, we can do all the stuff. We have a hooked whether this thing is triggered by another cell or not, kind of, yeah, tracking it manually, but it's yeah, and soon at the end. So doing the update mechanism, and then finally kind of returning the update every time the cell is run. And last part is kind of that we need to call the rerun function. So let's take a look here, and yeah, the rerun is called in the set update. So every time we set an update here, so then really the rerun is called. So this was a really quick one, but just that you know, so you can build this yourself by having macros, build all the states in the macro execution, and kind of have in the expression object which you return some special things like rerun cell function and register cleanup. And with this you can then build all these stuff. And finally, I think the time is rushing, I'm not sure. Yeah, I also want to show you that these things actually also work for Python, not yet in standard Pluto, but I just kind of did also some extra work to make this stuff working. So at Jolin, especially at Cloud.jolin, my focus is kind of to get these Julia tools also to everyone. And R and Julia support, R and Python support are one of my key things. And here the same is possible with some other kind of stuff built on top of it. But you can see here, this is a Python thread running in the background, just aggregating some random numbers on the Python queue. And we can do the very same, that we repeatedly grab from this Python queue and just use the Pluto updates. And this is now pseudo-random data, but yeah, it looks very similar to Bitcoin data, if you ask me. So, no, so yeah. And yeah, RxInfer does not exist for Python, so that's a case for Julia again. And yeah, so I think that's it. Thank you. And I hope you have time for one or two questions.
Yes, of course.
Perfect.
So, thank you, Stephan. Are there any questions from the audience? No questions? How easy was to use RxInfer? I'm quite curious.
Yeah, it was relatively straightforward. There's one key thing, that if you use Pluto reactivity with it, you need to kind of not use the standard way, because it has kind of its own mechanism of reactivity. And yeah, to circumvent this and use Pluto's reactivity, you kind of just need to know which methods to use. And yeah, but it's findable, and yeah, once you have it, of course, then it's kind of easy going. But this was the key thing.
Okay. Oh, good to hear.
Yeah.
Oh, yes.
Are the repeat take macro, is that running asynchronously in the notebook, or is it blocking the like?
Yeah, this is running asynchronously. So if you look at the repeat run macro, so every time kind of the cell is run for any reason, this code will be re-executed. Yeah, the macro code which we return. But then kind of on the update we sorry, where is it? Yeah. Sorry, I'm a bit confused here. Yeah, this is the part here. So this task is scheduled. This is here the async task where we set the updates, and this is scheduled then, and it's scheduled such that it's scheduled every time, as you see here. So it depends a bit on how you do it, but in this implementation of this repeat run macro, we schedule one task which is then run at a certain time kind of later on. Yeah, it's repeated at some time, and then it will just do the update and close itself. So to not have an ongoing running background task, but the next time this very cell is then re-triggering itself, it will spawn a new task.
And would it run on its own thread if you launch Pluto with multiple threads?
I guess it jumps them between the threads, yeah. Yeah. But this way has this is advantage that you can disable the cell. With PlutoHooks, sometimes if you have kind of a long running background task, disabling does not work any longer that well. But if you do it this way, that you spawn the task every time kind of on cell re-execution, disabling works automatically because the task is just not spawned again.
Thank you so much, Stephan. A big applause.
Thank you.